Welcome to the double angle formula notes. So here are our formulas, which allows you to find the sine of an angle twice as large as your given angle, cosine twice as large as your given angle, and tangent twice as large as your given angle. So the first thing we have is, one thing that we can do with these formulas is find the value of the trig functions. So, for example, find the value of the secant of 2u. First, we're going to determine the necessary formula. So if I'm doing secant goes with cosine. So I'm first going to find the cosine and then do the inverse. So I've determined I need to use cosine. So I have three choices. Does not matter which one you choose. Second, I'm going to use the trig values I know or can find to substitute into the formula. So out of simplicity, I'm going to do this one here, 1 minus 2 sine squared of u. So I need to find the sine value. So I'm looking at my angle here. So the sine of u equals opposite over hypotenuse. Well, what's hypotenuse? A squared plus b squared equals c squared. 9 plus 16 is 25, which is c squared, so this is 5. So sine is opposite over hypotenuse, which is 3 over 5. I plug into my formula. My formula says 1 minus 2 sine 2 of the sine value squared. Order of operations, 1 minus 9/25, 1 minus 18/25. Sorry, my pen isn't showing up. So then I do some math. This is 25/25. When I subtract, I get 7/25. So that is the sine of the angle that is twice u. So you could word it differently. It says find the value of sine of 2. Oh, sorry, that's the sine of 2u. Sorry, that's the cosine of 2u. So we need the secant, which is 25 over 7. Okay? So don't forget to do that final step like I just did. So let's go on to another example. Find the value of sine of 2u. This is another way to pose it. I don't have a triangle. Doesn't mean I can't do it. I don't have choices when I'm doing the sine. I need the sine and cosine values of my given angle. Here I'm given a quadrant. So that because I'm between pi halves and pi, I know my triangle's in this quadrant. I know cosine is -2/3. The x value must be -2, given the location. Hypotenuse is 3. I can solve for my my opposite side because I have -2 squared plus b squared equals 3 squared. So then I get 4 plus b squared equals 9. B squared equals 5. So this side is the square root of 5. So now I can use my formula, 2 sine cosine. So I'm going to do 2 times the sine value. The sine is going to be root 5 over 3. The cosine value is -2 over 3. Now I can multiply my fractions. Remember, that's 2 over 1. So I get -4 root 5 over 9. And that would be the value of the sine of 2u. Okay. One more thing. Sometimes we like to rewrite the trig function using a particular formula. So that comes in handy in context, again, in calculus when you need to find derivatives, etc. So cosine 6 cosine squared x minus 3. When you look at your formulas, you go, which one does it look the most like? It looks like this one, 2 cosine squared u minus 1. 2 cosine squared x minus 1. Well, it happens to be triple that value, because if you factor out a 3, you get 2 cosine squared minus 1. So I would rewrite this as 3 cosine 2x. Why that's helpful is now you have one item to find the derivative of, and you could find the derivative of that or the antiderivative. You could not do it of that with such ease. Now we're going to solve a trig equation. The problem with solving this trig equation is these have 2 different angles. That's an issue. I need them to have the same angle. So first I need to rewrite the equation using one of the formulas. So what I'm going to do is I'm going to look at the sine of 2x. because I can rewrite that in terms of x's. The sine of 2x is equal to 2 sine x cosine x. So this becomes 2 sine x cosine x plus cosine x equals 0. Notice now all the angles are x. That makes me able to solve it. So I can solve as usual. I would factor out a cosine x. 2 sine x plus 1 equals 0. Then I'm going to set each factor equal to 0. And then I'm going to solve. This one's already solved. I'm going to solve sine x equals -1, moving the 1 to the other side. And then I'm going to divide it by 2, the coefficient out front. So then I just need to find where the sine of x equals -1/2 and the cosine of x equals 0. So I go to my unit circle. On my trusty unit circle, I find the cosine is 0 at both, I'm going to use radians, at pi halves and 3 pi halves. I'm going to assume that I'm finding the solutions on the interval 0 to pi, inclusive of 0. And so the sine is -1/2 in two different quadrants. And that would be 7 pi over 6, the third quadrant, and 11 pi over 6, which is in the fourth quadrant. And those are my solutions. That is the end of our notes.